Algebra 1, Section 6.3, Solving Compound Inequalities. By the end of this lesson, you will be able to solve and graph compound inequalities. A compound inequality is made up of two inequalities. There are two types of compound inequalities, or compound inequalities and compound inequalities. The first type we will talk about is and compound inequalities. The solution to this type of inequality must satisfy both inequalities. Because it must satisfy both inequalities, the solution region is where the graphs overlap. So let's go ahead and take a look at this first example. Here we have a compound inequality. There are actually two inequalities here written as one. Let's write this inequality a little bit larger so we can break it up and identify the two inequalities. The first one is -2 is less than or equal to x. I'm going to go ahead and write that over here. The second inequality is that x is less than 7. And again, I'm just going to write that on the side. Now that we've broken up our inequalities, we can graph them. So I'm going to start by graphing x is greater than or equal to -2. Remember, it's important to always rewrite your inequality with the variable first. So I want a shaded dot where -2 is, and we want to represent all values larger than -2. And if I graph my second inequality, we want to represent values that are less than 7. Now if I take my lines and I overlap them, we'll see that they actually only overlap in between the two dots. So when you graph your compound inequality, it is only necessary to graph that overlapping region. So first we know that we're going to include -2 as a solution and not 7, but that overlap region is in between the two dots. Let's continue practicing some more compound inequalities. Here we already have our inequalities broken up. So we have x is less than 3 and x is greater than -2. So we want values that are larger than -2 and smaller than 3. So we have an open dot on -2, an open dot on 3, and we want to represent the values in between. Number 2. Here's our number line. We want values that are greater than -2, and we want values that are less than 3. So I've got -2, 0, and 3. We have open dots on both, and we're shading in between. Number 3. Again, we have two inequalities. X is greater than 4 and x is less than 10. And if we plot that, our graph, we would have an open dot on 4 and an open dot on 10, and we would be representing the numbers in between. Let's now talk about solving compound inequalities. Now, just like in an equation, our equal sign splits our equation into two parts. And in a basic inequality, our inequality symbol breaks the problem into two parts. With a compound inequality, we have two inequality symbols. So we're going to draw invisible or imaginary lines through our inequality symbols. And if you notice, we're dividing this problem into three parts. Now you still want to focus on the x, and you want to ask, how do you get x by itself? Well, here we would divide by 2. Now what you do is you divide all three parts by 2, and we get negative 4 is less than x, which is also less than 5. So the answer here is that negative 4 is less than x, which is less than 5. And if we graph that, we have our number line. We have negative 4. We've got a 0. We have a 5. Open dots on both. And we want to represent the values in between. Number 5. Again, we split our problem into 3 parts. But this time, to get x by itself, we're dividing by a negative number. Remember, if you divide by a negative number, you have to flip your symbol. Don't forget, that's very important. So 4 divided by negative 2 is negative 2. And if we flip the sign, we have greater than x. Flip this sign, which is greater than negative 4. So the answer is that negative 2 is greater than x, which is greater than negative 4. And if we put that on a number line, we have negative 4 and negative 2. We have open dots on both, and we shade in between. Number 6. Now number 6 has a few more steps. Again, we're still breaking our problem into 3 parts. But the first thing we want to do here is subtract 4. So you subtract 4 from all 3 parts. And when we do that, we get 2 is less than 2x, which is less than 6. Now we have one more step, which is to divide all 3 sides by 2. And when we do that, we get that 1 is less than x, which is less than 3. So the answer, 1 less than x, which is less than 3. When we put this on a number line, it is going to look like this, 1 and 3. We want an open dot on 1, an open dot on 3, and we're going to shade in between. Number 7. Again, we're going to break this into 3 parts. Now, if drawing those lines is not helpful for you, you don't have to do it. But some of you who are more visual, it might help. All right, first thing we're going to do is subtract 6 from all 3 parts of this problem. Negative 6 minus 6 is negative 12, which is less than or equal to negative 2x, which is less than 2. Next step is to divide by a negative 2. Again, we're dividing by a negative. So if we divide by a negative, we must flip our symbols in the next step. Negative 12 divided by negative 2 is positive 6, which is greater than or equal to x, which is greater than negative 1. So 6 is greater than or equal to x, which is greater than negative 1. And if we graph this, we have negative 1, 0, and 6. We want values less than or equal to 6, but greater than negative 1. All right, let's go ahead and move on to type 2, which are our OR compound inequalities. The solution to this type of inequality only has to satisfy one of the inequalities. So when we graph an OR compound inequality, you simply draw both graphs on the same number line. So let's take a look at this first example. But before we do, I want to change it. It's going to be x is greater than 5 or x is less than or equal to negative 3. So if we go ahead and graph this, x is greater than 5. We have an open dot at 5, and we want values to the right. If we graph x as less than or equal to negative 3, we have a closed dot on negative 3, and we want values to the left. All right, that's all there is to it. All of these values in the shaded area would be possible solutions to this compound inequality. So let's go ahead and just practice 2 more. Number 1, x is less than 0 or it's greater than 4. Again, here's 0, here's 4. We want values bigger than 4, or we want values less than 0. Very basic, that's all there is to it. So let's go ahead and do one more example. And here's our number line. We have a -1, a 0, and a 5. We want values larger than 5, and we want values less than -1. Alright, what's next? Alright, solve and graph each compound inequality. With OR inequalities, it's pretty basic. You just have two separate inequalities to solve. So let's go ahead and do them. Number 3, to solve the inequality on the left, we're going to divide both sides by 2, and we get that x is less than 3. Now if I look at the problem on the right, we're going to subtract 1 from both sides, and we get x is greater than 4. Now, it is very important that when you write your solution, you don't just box both of these as the answer. You must include the word OR, since this was an OR inequality. So our answer is that x is less than 3 or x is greater than 4. And if we graph that, here's 3, here's 4, we have an open dot on 4, we have an open dot on 3, and that is our compound inequality. Number 4. Again, do each one individually. Subtract 3 from both sides. 2x is less than -4. Divide both sides by 2. X is less than -2. Now we're going to do the other side. Add 5 to both sides. We get 3x is greater than 3. Divide both sides by 3, and we get x is greater than 1. So the solution is that x is less than -2, or it's greater than 1. And if we go ahead and graph that on our number line, here's 0, here's 1, here's -2. We want values going to the left of -2, and we want values going to the right of 1. Alright, let's scroll down. Writing your own compound inequality. Let's go ahead and write an inequality that represents the following phrase and graph it on the number line. All real numbers. Remember that this is our phrase that represents our variable. So we want all real numbers that are greater than 0. So all real numbers greater than 0. And, now you can write the word and in between, less than 4. Well, what is less than 4? All real numbers. So we would start with our x again. So all real numbers have to be less than 4. Now this is an acceptable inequality, or you can rewrite it with your variable in the middle. To do that, you always use less than symbols, your variable is in the middle, and the smaller number goes on the left. And that's all there is to it. So if I want to graph this, here is an open dot on 0, 1, 2, 3, 4, an open dot on 4, and we shade in between. Now in our second example, all real numbers, again, there's your variable, less than -1, and now we're using an or greater than 2. What's greater than 2? Our numbers are greater than 2. So there's your inequality, and remember you cannot put that together. So to do this, we have -1, we have an open dot, and we are going to the left. Over here we're at the 2, we have an open dot, and we're going to the right. Now, if I didn't mention this, to identify the difference between an and an or inequality, it's simple. All or inequalities will always have the word or. Now it's your turn. Do some practice